Hi guys, welcome to Wisdom Academy YouTube channel. Today we are going to see about inverse trigonometry function. This is the second chapter in the NCERT class 12th. Okay, what is the meaning of inverse function? In our last chapter itself, we saw what is the meaning of inverse function, right? And you already know what is trigonometry function in class 11th, right? So now a function, trigonometry function, inverse. It's no new word is there, right? All the words you know already. Inverse you know, trigonometry you know, and functions you know. But you know it as separately. Now we are going to see it as together. Okay. So why we need to study this? So whenever we are going to study a new chapter, we want to ask why we are studying this, right? Why we need inverse function. Without inverse function, what is going to happen in the world? Nothing, right? So in that way, if we discuss, so inverse trigonometry function is the one which is very much required for pre-calculus. If you are going to touch a calculus, before that you should definitely know about the inverse trigonometry function. Then only you can able to proceed with calculus. So in next few chapters, we will also see our calculus in our chapters. So to make it ready, this chapter is a base. So give some little extra concentration so that you can able to do good in calculus also. Okay. So if I say practically or a real-time example where I can use my trigonometry function, that is inverse function, is I can take a scenario like this, one of the famous this thing, that's a movie theater screen problem. So what is this? The statement says that there is a 7-meter long screen and 2-meter long, it is above the 2-meter above the line sight of the viewer who is viewing this, and I'm going to take it as an x meters inches away, and I want this angle. I want to this angle I need. Okay, so how to find this angle? How to find this angle? So it's very simple, right? What I can do, if I take this triangle, that is a smaller triangle, I will take this as in theta 1 now, as of. So I will take this theta 1, and from that tan theta 1 can be written as 2 by d, right? Because opposite is 2 here and adjacent is d. Sorry, here it is x actually. I will make it to d. Okay. So if I continue the step for this whole triangle, that is whole right angle triangle, and my tan theta is going to be, I will take that as an theta 2. Okay. So tan theta 2 can be, now opposite is 9 because 7 plus 2 is 9 and distance is always same, right? I will take it as d. Okay, so tan theta 2 is equal to 9 by d. Similarly, now I want to know only this angle, right? I want to know the viewer, how he is viewing the screen. This theta I need. Okay, I will take this as theta final. Okay, so theta final will be always equal to theta 2 minus theta 1, right? Okay, theta 2 minus theta 1. What is theta 2 here? Theta 2 is this one, right? I want theta 2. I can't able to take tan theta as equal to, right? So I want theta 2 here. Now I will replace my tan there. Now the tan crosses this equal to, what will happen is theta 2 will become tan inverse of 9 by d. Similarly here, theta 1 I need. So what I'm going to do? Tan inverse of 2 by 9. This inverse, many people will confuse with reciprocal. Okay, so don't confuse with reciprocal, which is not reciprocal. If a normal person can say that sine inverse of x is not 1 by sine x. Okay, don't confuse with these things. Anyway, in later what I will explain that also. So now we can come to this sum. Now you see what is theta 2? Theta 2 is tan inverse of 9 by d minus similarly tan inverse of 2 by d, right? Because this is theta 2 minus theta 1. Okay, so this is the way we can able to find, and see, to show the inverse function where it is a real-time use, to show that I have taken this sum. Okay, so next what we are going to see is just a flashback of your class 11th. That is, now it's just forget about your inverse. You just concentrate on your trigonometry functions. Okay, only trigonometry functions you concentrate. In this flashback, what we are going to say is I want to say about the domains, ranges of the each thing. So now if I take a sine function, what will be my range? What will be my domain is R, right? R means a real number. Okay, any real number I can give it as an input, but I will get answer only in between -1 to 1, right? If I remember the sine graph, you will come to understand. Whatever real number I can give, whatever number I want, I can give, but what I will get is only up to 1 or -1, 1 and -1, right? I can't able to get more than 1 and -1. So that's why similarly a cos is also. Okay, these are the two functions. I'm going to show this now. This is tan function, right? Tan function, real number, all real number cannot come because there are some chance of infinity. So I want to remove that. So wherever my pi by 2 is going to come, that is in 2n plus 1 pi by 2 is going to come, that place alone I will remove. That is my odd pi by 2. Okay, so that place I am going to remove because in that place I will get infinity as an answer. So actually in my graph, in that place, that is pi by 2, the value for tan will not be there. This will be denoted by dotted lines if you remember your class 11. And that is why, and so other than this minus represent in the real number, other than these numbers, what I are going to add it, other than this number, and it is related to R. Okay, because the sine function will go up to infinity, not like a sine or tan function will go up to infinity, not like sine or cos. It will limit to 1 to -1. So it will go to all the real numbers. So it can go, it can take any real number. Similarly, cot here, it is cot function cannot be a n pi, right? Because in n pi it will take to infinity. Okay, so these things you might be stated in your class 11th, right? So make a note of this. These things we are once again going to use in this chapter. Okay. So you want to remember your unit circle also. So from how the unit circle we are going to get the cos sine, and once again by dividing sine by cos I will get the tan, and once again by inverse of sine I will get the cosecant. Like that way I can able to make a graph, but the unit circle gives only these two graphs, that is sine and cos. Using this, how if my angle increases, how my sine and cos waves are being drawn. So okay, so inverse function. Now we can talk about inverse function. Now you forget the word trigonometry. Okay, now if I take a function, okay, in first unit also I teach it, that is in the unit of functions I teached. If I want to check whether the function is having a inverse or not, what I will do, I will check whether it is an bijective function. First, what I will check whether it is a bijective function. What is the meaning of bijective function? A function which has one-to-one function. So the given function should satisfy both one-to-one function and onto function, right? The function which satisfies these both, I will say it as bijective function. Definitely x square is not a bijective function because answer 4 can be taken for 2 and -2, right? So it cannot be a bijective function. If a function is not a bijective function, then we normally call it as it is not a invertible. I hope you guys are remembering this. Invertible means the function which doesn't have inverse. Okay, not invertible means it doesn't have any inverse. Okay, now I will take my trigonometry function one by one. Okay, let me take sine as an example first, right? This is how my sine wave will be, right? This is how it will be, and here also it is keep on going on. Sorry. So it's going to be like this, right? That's the way it's going to go. This is my y-axis and this is my x-axis, and here it will be 0, and here it's going to be pi, and here it's going to be 2 pi, and here it's going to be pi by 2, and here it is going to be pi by 3, and here it's going to be, it's going down. Okay, now if I see here whether it is an one-to-one function, because to have a inverse function I need to satisfy a function to be a bijective. Now I have taken sine as an example. I've taken sine as an example and I'm checking whether it is an one-to-one function. Definitely it is not an one-to-one function. Why? Because I am getting answer as 1 in several regions and similarly 0 as in several regions. Then how it can be forming a inverse function? Now how one not a bijective function can form a inverse function? It contradicts with unit 1, right? Unit 1 says that is a function which is bijective only can form a inverse function, right? But I am going to use the word inverse trigonometry function, right? So trigonometry function can be a inverse with some restriction. Now somehow I want to make this graph or somehow I want to make this function to be bijective. For that what we are going to do? So to make a sine wave or to make a sine function to be a bijective function, some restriction we are going to make in domain. Okay, and also in codomain. So how we are going to make this, how we are going to do this restriction, that is what we are going to see first to know about the inverse function. Okay, so if I take a, this is normal sine function, right? Okay, now this is a normal sine function which is drawn. Now using our method, somehow I want to make it to be a bijective function, right? So I should not get more number of ones, right? I should not get more number of ones. I should not even get more number of zeros. Okay, so the way is by restricting the domain. Somehow I am going to restrict the domain. So in what way if I restrict, this function will become an one-to-one function, or in simple words it's a bijective function. How to make it as a bijective function? So for that, a first obvious choice is going to be like this, right? What I will do, I will try to take from here to here only one loop. Okay, for anybody's obvious choice will be like this, but definitely this is not a one-to-one function. Why? Because I am getting 0, 1, 2, 3 times. Okay, I am getting 0 3 times, and even this part, that whatever it is increasing, that is 2 times I am getting here, right? So definitely this is also not a one-to-one function, so it cannot be a bijective function also. Okay, then what is the other way so that I can able to select? So other way is, what you can think is, see, that is other way, I can select from this to this, right? I can able to select from this place to this place. Okay, now you see here, from here to here, no values has been repeated. I can't able to say, right? So if I take from 0 to 2 pi, it is not coming. But if I take pi by 2 to, that is minus pi by 2 to plus positive pi by 2, what I am getting, by reducing this interval, I can make a sine function to be a one-on-one function and onto function, so it is a bijective function. So for this graph I can able to provide a inverse function, right? For this graph, that is limiting from pi by 2 to minus pi by 2 or minus pi by 2 to pi by 2, I can make this function as an inverse function. So now you see, this is the portion. If I select minus pi by 2, minus pi by 2 to pi by 2, this will be the portion, right? Now no value is repeated, it's going to be one-on-one function really. So now the process is not finished. Now still it is a sine function. I want to make it to inverse. What inverse means is, if I'm having f of x, I'm getting the answer of some y, then f of y should be x, right? So literally here x means x-axis and y means y-axis. Now I'm going to change this in my x-axis y-axis format, because inverse says that f inverse of y will give me x. So what output I'm getting here, if I give it to this function, I will get x as an answer. So to do that, I'm going to change the graph little. So by changing that, I will get graph like this, right? So I will get graph like this. Okay. So now what I changed in my y-axis, I am having my range, that is pi by 2 to minus pi by 2, and in my x-axis I am having minus 1 to 1. So that's why it is inverse, right? If I take the sine function, my this x-axis and y-axis is now changed, right? So this is now the important things what you want to keep it in your memory is y is equal to sine inverse of x if one and only x is equal to sine y defined for this range, that is minus pi by 2 to pi by 2, and this value can come only up to minus 1 to 1. In this way I made a sine function to be a bijective function. So by after making it to be a bijective function, I can able to take a inverse. Okay, now we done for sine. Similarly, I am going to do it for cos also. So for cos nothing is going to change much. Anyway, what is the range is now cos. Little you think this is the cos function. So to do that, from this place to this place, from this place to this place, you can able to feel it has only one to one function, right? Okay, so a little change from the sine function, it's going to be like this. By restricting my value from 0 to pi. Okay, now for if you remember in sine we kept minus pi by 2 to positive pi by 2. Now here it is going to be from 0 to pi. The no repetition of value is there. Now using this I can able to draw. Now it is also a cos function which is bijective. This is also a cos function which is bijective next. But I want cos inverse of x, right? Cos inverse of x, what I have to do? I want to change my x-axis, y-axis. That is inverse function means if I get the output, if I give the output as an input, I should get my input as an answer. So to do that, what I'm going to do? I'm just going to change my axis. So that is x-axis and y-axis going to be changed, and my minus 1 and plus 1 value will be there. And here also my cos function y is equal to cos inverse of x is only possible if it is ranges to minus 1 to 1 and my value is going to be 0 to pi. If it's that possible only, we can able to make a inverse function. Okay, sine and cos not gave you any trouble, but if I go to a tan function, it will have something new. How to make the tan function? This is the tan function what you studied in your class 11th, right? So how the tan function graph is going to be. The very inconvenient thing is I am going to have no value in pi by 2. Whatever pi by 2 multiples of pi by 2. Okay. Okay. So odd multiples of pi by 2, I doesn't have any numbers. That is, this is another odd numbers. 3 pi by 2. And here also 3 pi by 2. I will have infinity as an answer. So now from which place to which place I have to think? I have to take as an answer. For that, if I examine the map little, by this, if you have observed the video properly, you might be thinking from which place to which place will be a tan inverse is possible, right? Now what I am going to do? I am going to take this part alone, right? This part alone will be my one-to-one function or just a bijective function from this part to this part. Okay, I eliminate all other parts. Okay, I add many parts. I have taken only little this part. This part will act as an one-to-one function. At the same time, it will act as an one-to-one function. Simply, I can say it as bijective function. Since now this function is bijective function, I can able to make it through inverse of this, right? So if to make inverse of this, what I will do, I will change my x-axis, y-axis. So what is new in this is I am not going to limit my answer to minus 1 to 1. Why? Because a tan function can go to whatever value what it want, right? Whatever value it want, it can take. Okay, so just comparison here. You just see here in the tan function, if I say how it will be related, minus pi by 2 to pi by 2. Okay, in that range. This is minus pi by 2 to pi by 2 range will be related to real number. Now in tan inverse, real number will be related to minus pi by 2 to pi by 2. Okay, so this way we can able to find here that there will be no restriction on x-axis, that is in inverse, that is it should be in minus 1 to 1, not like that. It will keep on going, right? So this graph is its approaches infinity, and this also approaches infinity. So This is another graph what we have seen. Now we have seen three inverse functions. One is sine inverse of x, and cos inverse of x, and tan inverse of x. Okay, inverse is only possible by restricting my domains. Okay, now what will be the reciprocals of these functions? Okay, so to do that, you have a practice of these three graphs first, and graph is very important here, and it's not just mugging up the graph you want to be analyze. So what place, what value is coming, why this value is not coming there. So these kind of analyzation will give you the analytical skill in the math. So take this as a point, and this is one of the easiest unit. Nothing to worry about it. It is going to be hard, but if you are missing this unit, if you are not studying this unit properly, you guys are going to struggle in calculus things, because this is one of the important pre-calculus thing you want to read. That is in calculus, then that is in integration and differentiation, what we are going to study in next half of the 12th, you will get struggled. So please be little concentrated on this unit, and definitely it is a mark fetching unit. Why? Because it will not take much time. If you know all the formulas, if you know all the tricks, you can able to solving sums will not give you much problem in this unit. Okay guys, in next video what I am plan to do is I am going to take all the reciprocal of this thing, that is my tan inverse, that is cot inverse I am going to see, secant inverse I am going to see, and I will also see about the cosecant inverse. So how we are going to deal with that kind of reciprocal ratios. Okay, thank you guys.